discuss another technical words we can use in this chapter, that is conductance. Conductance is denoted by the symbol of capital G. Conductance is denoted by the symbol of capital G. Now what is a conductance? Reciprocal of the resistance is called conductance. Reciprocal of resistance is called conductance. It is denoted by the symbol of which one? Capital G. Now G is equal to 1 by R. G is equal to 1 by R. Now what is the unit for conductance? The unit for the conductance is ohm inverse. What is that one? Ohm inverse. We can read this as per ohm also. Ohm inverse or per ohm. Otherwise we can write the ohm in reverse order, MHO, mo. It is also, we can take the unit of the conductance. And another unit is also there, that is Ohm's name, that is Siemens. In the Ohm's law I am said, what is the full name of the scientist Ohm? George Siemens Ohm. Ohm is taken unit for the resistance, but Siemens is the unit for the conductance. Conductance means reciprocal of resistance. Okay. Now conductivity, this word we frequently use in this chapter, especially in the electricity chapter. We can use maximum conductance word. What is the symbol for the conductivity? Conductivity symbol is sigma. Conductance is capital G. Next one is conductivity. Now what is the conductivity? This word also we can frequently used in the electricity chapter. Now what is the conductivity? Reciprocal of resistivity. Reciprocal of resistivity is called conductivity. What is the symbol for the conductivity? Sigma. Sigma is the symbol for conductivity. How we can write sigma? Sigma is equal to 1 by rho. What is the rho? Rho is a symbol for resistivity. And we know the unit for the resistivity. In the last class we are studied that resistivity unit is ohm into meter. That's why it is per ohm and per meter. Per ohm, per meter, or ohm inverse and meter inverse. This is the unit of conductivity. Otherwise we know that one ohm inverse is also called by the name of George Siemens as Siemens. Siemens into ohm inverse. This is the unit of the conductivity. Okay, next. In this chapter we establish a relation between J, sigma, E. This principle especially we used in the 11th chapter. This relation in this chapter also we can use to solve the problems, and not only that, we can compulsory used this equation in the 11th chapter in our syllabus. I will repeat again that in that chapter. J, current density. Sigma, conductivity. E, intensity of electric field. J, current density. Sigma, conductivity. E, intensity of electric field. Now what is the relation between them? We know the mathematical expression for the conductivity. What is the mathematical expression for the conductivity? J is equal to I by A. According to Ohm's law, I is equal to V by R. J is equal to I by A. According to Ohm's law, I is equal to how much? V by R. And again V is called potential, electric potential. We know the relation between electric potential and intensity of electric field. What is that one? V is equal to E into R, actual R. But instead of R, what we can take? L. E into L. Okay. RA by L. RA by L is equal to how much? 1 by sigma. Sir, 1 by rho. 1 by rho is called resistivity. L by RA is rho. 1 by rho is equal to how much? Sigma. R by LA is equal to how much? 1 by rho. 1 by rho is equal to how much? Sigma. That's why what is the relation between J sigma E means J is equal to sigma E means conductivity. Sigma is multiplied by intensity of electric field is equal to current density, or current density is equal to product of conductivity and intensity of electric field. This relation. And next, another important question in this chapter, that is drift velocity. Drift velocity. One time we can get one problem based on this drift velocity. Now, what is the drift velocity? Drift velocity means constant velocity. Drift velocity means constant velocity. Let us take this is a conductor, it is a wire. The current passing through this wire, we have studied in the last class as the ends must be connected by the battery, otherwise it must be kept in the uniform electric field. If it is not kept in the uniform electric field, in the conductor free electrons are exist, but that moves randomly. In the conductor free electrons are exist, that moves randomly, that's why we doesn't get the current. When the ends of the conductor connected by the battery or the conductor kept in the uniform electric field, then the current flows through the conductor. Current flows through the conductor. Current flows means the charges flows through the conductor, the charges flows through the wire. In that situation, we use the technical word is drift velocity. In that situation only, we are already studied about the resistance. Resistance is oppose the flow of current. The inherent property of the conductor oppose the flow of current. Flow of current means flow of electrons. Now, how it is, now let us see. First, I want to explain this diagram, then after we will go to the definition. This is one conductor like this. The cross sectional area is A, length is L. Now, this conductor kept in the uniform electric field. Kept in the uniform electric field means which charge is present here? Positive charge. Here, negative charge. Why? It is electric line of force. Electric line of force starts from positive charge and at negative charge. Means here which charge is present? Positive charge. Here which charge is present? Negative charge. Means this is the uniform electric field. When the conductor is taken in the uniform electric field, these all are the electrons. Before these in the electric field, these electrons moves randomly. When this conductor taken in the electric field, these electrons are moves in the opposite direction of electric field. Why that are moves in the opposite direction of electric field? Here which charge is present? Positive charge. Here which charge is present? Negative charge. Electron, negative charge. What happened? Repulsion. Electron, positive charge, attraction. That's why in the conductor, electrons are moves in the opposite direction of external electric field. At that time, let us take this is the one electron, this is another electron. This is one electron, this is another electron. This electron moves in this direction. This electron moves in this direction. But it is a negative charge. It is also negative charge. In between them, repulsion as well as collision. Why? Here which charge is present? Negative charge. This is negative charge. In between them, repulsion is more. That's why it moves very fast, but it is a negative charge, strikes that one. Collision is occurred, bounce back. Bounce back. It is also strikes this electron, bounce back. Again here which is present? negative charge. This negative charge again repels this one, moves and strikes this one, means collision is occur and bounce back. Means, okay, this electron strikes this one, this electron moves in this direction. This is electron, this is electron. This is negative charge, this is negative charge. Again between them what happened? Repulsion is occurred. So it touch and bounce back. It is also touch and bounce back. It is also touch this, bounce back. It is also touch and bounce back. Means when the conductor is taken in the uniform electric field, electrons are moves, but electrons are opposes by the electrons. Electrons are opposes the electrons. Charges are opposed by the charges. Nothing but inherent property. Who is opposed that? Electrons only oppose the another electrons. This is an inherent property. That inherent property is called resistance. That is called resistance. Now, this electron takes the number of collisions. Finally, these electrons moves from one end to another end in the opposite direction of electric field with a constant velocity. That constant velocity is called drift velocity. Vd, drift velocity. Okay, when the conductor is taken in the external electric field, in the conductor, electrons are moves in the opposite direction of electric field, but electrons are opposed by the electrons. So the one of the inherent properties is ejected, that is called resistance, so that the electrons make several collisions or number of collisions and gets constant velocity and moves in the opposite direction of electric field. That velocity is called drift velocity. That's why what is the definition? Constant velocity. Velocity is constant, achieved by the electron or electrons in the conductor. Electrons in the conductor after number of collisions and travels in the opposite direction of electric field is drift velocity. E is called drift velocity. Drift velocity denoted by the symbol of Vd. Okay. Now let us take this diagram. In that one, number of electrons in the conductor is Ne. Electron symbol is E. Number of electrons, that's why Ne. Next, charge in the conductor for flow of current is, what is equation for the current? I is equal to Q by T. Now what is a Q? Q is equal to how much? Number of electrons, Ne by T. What is I? I is equal to Q by T. Then what about Q? Q is equal to Ne by T. Now we know that one, current density. What is the symbol for the current density? J. J is equal to I by A. Now what is the symbol for current density? J. Now from that we want to establish the equation for the drift velocity. Now current density is J. J is equal to I by A. Now J is equal to I by A is equal to, what about I? Q, I is equal to N E by T into 1 by A. Now N E by T into 1 by A, I am multiplied by L and divides by L. So what happen means J is equal to N E by T into L by area into length is called value. So we can write N by V into E into L by T. Shall we write like this? Now J is equal to N by V, means you take small n into E into length by time velocity, but it is drift velocity, so we can write like this. Now what is the equation for the drift velocity? Vd is equal to J by Ne. This is the equation for the drift velocity. Vd is equal to J by Ne. Otherwise Vd is equal to J is equal to how much? I by ANE. ANV. Okay, if we can simplify, we can write like this also. I by ANE by V. No need of this. This is enough up to this. This is the equation for the drift velocity. This drift velocity is 10 to the power of -4 meter per second approximately. Drift velocity is approximately equal to 10 to the power of -4 second in the conductor. Why? N. What is the N? Number of electrons per unit volume. Let us take unit length and unit cross sectional area of a conductor. In that one, the drift velocity approximately equal to how much? 10 to the power of -4 meter per second. Okay. Now another one is there. We want to derive that. That is called mobility. What is that one? Mobility is also considered under the which one? The drift velocity. Now mobility. What is that one? Mobility. Now symbol of mobility is mu. Now but how we can define mobility means mobility mu is equal to Vd by E means drift velocity per unit intensity of electric field is called mobility. This is the equation and we can write unit for this. Now what is the unit of the mobility means drift velocity is meter per second and it is volt per meter. That's why the value is meter square by volt into second. This is the unit of the which one? Mobility. Now what is the use of the mobility means the current flows through the conductor. The current flows through the conductor by the electrons or by the protons. It is identified with the help of the which one? Mobility. Okay. This is the one of the important topic under the drift velocity.